Welcome to mining the data. So the method we're going to use to simplify problems is to divide our problem solving into three parts: the wanted, the data, and then the solve. So this method breaks our complex problems into smaller, easy to manage steps, because you're always going to know what to do next. These three steps will work with all of our chemistry problems. And to solve word problems, the key is to get rid of the words and just use the numbers and units. So by translating our word problem into numbers, units, and labels, we can then solve most problems in a first semester chemistry course by chaining conversions, as we've learned in chapter 4. And when translating the words, we want to write in the data section of our paper every number that we see followed by its unit and a label describing the quantity being measured. First off, read the problem. Write down the wanted, question mark, followed by the wanted unit and an equal sign. And then on the next line, write down data, Then go back and read the problem a second time. And every time you find a number, stop. Write the number on a line under data. After the number, write its unit, and then write a label that identifies what that number is. Decide if that number, unit, and label is paired with the number, unit, and label as part of an equality. So in the data section, write each number and unit in the problem as part of an equality if it is part of one. So if you see per or a slash, or then you want to write a per or slash as an equal sign in the data section. If a number is shown after per or the slash, then write the number in the equality. So if you read $8 per 3 pounds, then you want to write in the data section $8 equals 3 pounds. If no number is shown after the per or slash, then you want to write the per or slash as equals to 1. For example, if you read 25 kilometers per hour, then you want to write in the data section 25 kilometers is equal to 1 hour. And these statements can then be used as conversion factors in your problem solving. You're going to treat unit x times unit y minus 1 as unit x per unit y, or unit x slash unit y. So if you see 75 grams times milliliters to the minus 1, then you're going to write 75 grams equals 1 milliliter, just as you would if you saw 75 grams per milliliter with no exponent there. If the same quantity is measured using two different units, then we want to write the corresponding equality statement. For example, if a problem says 0.0350 moles of gas has a volume of 440 milliliters, then in the data section, you want to write 0.0350 moles of gas equals 440 milliliters of gas. If a problem says that a bottle is labeled 2 liters, and then in parentheses, 67.6 fluid ounces, then we know that inside that bottle we have 2 liters, and we also know that the volume is 67.6 fluid ounces. So we now have two different measurements of the same quantity, so we can say 2 liters equals 67.6 fluid ounces, and now we have a conversion factor between liters and fluid ounces. If the same process is measured using two different units, then we can write out the equality statement. For example, if a problem says burning 0.25 grams of candle wax releases 1,700 calories of energy, then we can write in the data section 0.25 grams of candle wax equals 1,700 calories of energy. Note that here you should always include the label, and these labels, candle wax and of energy, help us to identify what the quantity is a measure of and will help you in solving the problem. For example, if you burn more than one type of substance, if you're burning candle wax and, say, gasoline, and you're trying to figure out which one has a greater energy density, so energy per mass, you want to keep those labels in your problem. As you get more advanced in and more comfortable using this system, you may decide to drop some of these labels, but initially you should keep them in there to keep track of what exactly it is that you're doing. So keep an eye out for words that mean one, such as each and every, and these represent one, which is a number and should be in your data section. For example, if a problem says each student was given 2 sodas, then you want to write 1 student equals 2 sodas. And now we have a conversion factor between students and sodas. So we're going to continue doing this until all of the numbers in the problem are written in your data section. While writing the wanted, you should write per 1 as a ratio unit and per more than 1 as a single unit. In the data section, however, you should write per 1 and per more than 1 as equalities, because we're going to use these as conversion factors in the solve portion. That is, per 1 and per more than 1 are treated differently in the wanted section, but they're treated the same in the data section. So that was mining the data.